Hey everyone, I'm Gunvail, and today I wanted to go through a case study of what to do when you're facing an unknown network protocol, which should allow you to download a file, but, well, because it's an unknown protocol, you cannot really download that file. And this is actually an intro, or rather a showcase of what you will learn if you attend my Mastering Binary Files and Protocols, the Complete Journey course, which is starting April the 8th, and it's basically like 14 meetings, 50 hours, and a lot of exercises in between. So yeah, what can you learn on this training? Let me show you. And basically everyone after this training should be able to solve a simple protocol like this. I'm going to use two tools. One is a Wireshark, where I have a pickup of the protocol, the download protocol. It has been observed basically something downloaded one file, but it's not the file we want. We want to download another file. So to do this, we have to reverse engineer this protocol and implement it in Python, and this is what I'm going to do now. Now, if you actually go through my course, you don't really need Wireshark. You can just operate on pickups in a hex editor, but let's just use Wireshark for now. So what we can immediately observe is that, well, there's a lot of UDP traffic, quite a lot actually of packets. There are like almost 100 packets, and two computers are chatting. Like one is this Asus Tech Comp, which is on the IP, let's make it a little bit bigger, 192.168.2.198, and this is the client, something which downloaded the file, and the server, which is hosting actually the files, is on this IP 192.168.2.4. So 198 is the client, 4 is the server. I also have a text editor, basically, to make notes, so this will just make it easier for me to note down what I observe in Wireshark. Okay, so let's go through it. There are like multiple layers basically in a network protocol. We focus only on the data layer, basically on the payload of the UDP packet. We are using the UDP protocol, which means there is no connection, just packets are exchanged without a connection between the client and the server. So initially the client just sends 0. So we have client sends to the server just 0. And yeah, I have no idea yet what that is, but this is what we are going to figure out. And to this, the server replies with, yeah, actually it replies with a list of files. We can immediately see it in plain text, but it says, oh, there's readme txt and boring PDF and secret PDF, which is cool. So let's copy this packet, basically, this as Sherbas. Yeah, we want to copy them as hexdump, basically. Is this what we get? Yeah, perfect. But we have copied the whole protocol. However, we are only interested in the payload. So it starts with 0386. 0386 is here, as expected. So we can remove this. We don't really need the offsets either. So yeah, this is the protocol. Now what we know is we know that there are file names, and the file names are basically like starting here. This is the 52, 45, 41, 44, which is this. Yeah, and the file name basically ends at this T here, which is like 54. So I'm just going to split it. So yeah, okay, now I've splitted it. Now the next name begins with this B here, which is 42. So I know that this 42 actually belongs to the next name. And my guess is that it ends around here, 46. This, like 2E is actually a dot in ASCII. So this is going to be likely PDF. Then we have another 5 bytes, and we start with another printable ASCII range. This is the first 53, and this is the S here, the secret here. Okay, so we get this, and then, yeah, and this is just the file name. So what we can see here, I guess if I like just align it, is that we are getting interleaved. Like we get this 03, which can be the file count, right? Like we can immediately think that, hey, 3, well, 3 makes sense if it's a file count, because there are 3 files, readme, boring, and secret, right? 3 files. So this is likely the file count. And then we have this, and I have absolutely no idea what this is. This A here is interesting because, well, it is in all cases, like there's this A. A is 10 decimal. So a hexadecimal is 10 decimal, and maybe this is the length of a file name. Let's count the characters. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I know this is actually the length of the string, which is a pretty typical way to actually encode strings, having some kind of a length prefix. And then we get the name. This leaves this pretty random number here, and I honestly have no idea what this is. So yeah, I don't know yet. So what I know so far, and let's make a note out of this, is to get a list of the files, we have to send this. Like the 0 here, get a list of files. And then the server will reply with the file count, and then like some random value, the length of a file name and a file name. And it does this like this amount of times. So knowing this already, we can start implementing the client. So to do that, I'm going to use Python. And I already have like a boilerplate code written which connects to the server at the proper port. It uses the socket datagram connection in the internet family, which is UDP basically. And the timeout is set to 2 seconds. So if something doesn't work, it will just like timeout after 2 seconds. And I've created this function because this is a request response protocol where the client sends a request and then the server responds with a response. Well, responds with a response, yeah. Then we can already implement that, and I have a function which sends to the socket, to the server, from the client, some data, and then it receives some data up to the size of the maximum UDP payload, basically, and it returns it. As such, I know that if I'm going to send 0 as data, well, I actually have to do it like this, then I should get a file list. So let's just call it get list, and I'm going to get back some data. And what I want to do is I want to actually maybe get this list, and I want to print the list. So let's do pprint here to get the list. Now I send the data, but now I need to process it. I know the protocol, right? So the first byte tells me like how many files there are actually. So the count, the amount, is going to be data of 0. I'm going to assume that the protocol actually works, that is correctly implemented. And now I need to actually go through this packet. I, for me, is going to be just the offset in the packet, like the byte offset from the beginning of the packet, or rather from the beginning of the payload, UDP payload. And I'm going to do this count times. Now, what I know at the beginning is this value, and I have no idea what this value is yet. Maybe it will become clear later, but for now I'm just like, it's just like unknown to me. And that unknown is like, I need to grab like 4 bytes from there, and I is going to be my like pointer or iterator or offset from the beginning of the packet, so I'm just going to increase it. So I grabbed these 4 bytes, put them in unknown, again, I don't know what they are, and then I'm going to get the length of the name. So let's call it like name size, maybe. And I'm going to iterate move I by another byte. So now I have this size, and now I can just grab the name, which is going to be, I guess, well, I'm going to have bytes returned, and I'm grabbing it from I to I plus name size, because we already have name size, and I can move I by this like name size. So let's move it. And I have now everything I need. Let's just make, well, actually what I need to do here is I need to also decode this. I'm guessing that's going to be like UTF-8, but I don't even have to specify it. I can just do .decode. And I need to do a list of files. So maybe let's call the list of files. And here I just can add everything I have to this list. So files append. And what do I add here? I actually want to add everything, I guess. So I'm going to add the unknown first. Let's just like convert it to hexadecimal for easier representation. And then just the name, right? I don't need anything else, so just the name. Okay, and then at the end I just return files. So let's test if this works. I need a console to do that. And yeah. We got a list of files. Cool. So we have the README, the boring, and well, we want the secret, right? It's pretty obvious that we do want the secret. So how do we download a file though? Like, let's go back to this protocol and see maybe maybe the client does download the file. So, well, first what it does, it requests this file list with 0 here in the payload. And then in the second request, it downloads the file list again for whatever reason. Okay. The next packet is different. So let's copy actually this. It's from 0186. So let's do here, paste this, and actually I don't need here. This is the start of the packet, so I just need this part, and I don't actually need this either. I just need this. There we go. Okay, cool. So what do we have here? Well, first of all, this like 00 is no longer there. Instead, we get like 01, which is, I guess, a different command. Then we get this sequence, which is actually identical to this sequence, right? Like 86, 02, B6 to D, which tells me, I guess, that, hey, this is actually like the file identifier, maybe the file hash, maybe some unique ID. I have no idea, but it seems like to be the file ID. So what I'm going to note is that likely I am downloading data here. Yeah, I am downloading data. I can see in the response. Now what I checked, right? But I'm guessing, sorry, what was this for? Or I guess we can look at the client. 8602 was the README, right? So I think that was a fetch command for the README file. And I got the README file, which is great. So I know this is the file ID, which I sent here, and then zeros. I don't know why would I send zeros, but I guess we can already implement this and check if we can download the secrets file. So let's make another function, get file, and I guess I need to specify the file ID here. Yeah, I know I'm shadowing the ID function, but that's okay. I'm not going to use the ID function anyway, so I can shadow it. Okay, so the request is going to be a little bit more interesting. I need the struct module, which I do have. So what I'm going to request this time is, well, first of all, actually the command doesn't change. So I just send, or rather it changes, the type doesn't change, but what changes is the actual number, and that's 01. So then I need to send the ID, and actually what I need to send is, because I have this ID in this like textual format, in this text format, right, like hex encoded, I have to do from hex of the ID, and let's assume that I'm just going to pass this ID as in hexadecimal representation. And then what I'm sending is these zeros, but I have no idea what that is, so I'm just going to do struct back, and I don't even know if it's little endian or big endian, so yeah, let me just add zeros there. This is going to like emit 4 zeros for me. Why 4? Because I, for struct packed, denotes a 32-bit unsigned integer. And it's little endian due to this marking in the format. You can actually look it up in the documentation. Now let's move this window, a little bit. Okay. So request is sent, and then I'm going to get some data, I guess. And I have no idea what I'm going to get, so I'm going to just like print it for now. Let's do it like this, maybe. I'm just going to print the data, and then what I need is here, I need to do actually get file and the ID, which I'm going to copy from here as a string. Okay. Okay. And it got me this 01 at the beginning, and then welcome to the file server. So this works. Now let's switch to getting the secret. Okay, it got me some data. And it's a PDF, but a PDF doesn't have like this 01 at the beginning, which is a little bit weird. And also, there isn't a lot of data. Like PDFs are usually longer, so I'm still missing something. What am I missing? So let's see, let's continue looking into Wireshark. Here we are fetching, is it the same file? Or I think it's another file in this case. It's fetching this 8602 B6 to D. Oh, and look, these zeros have changed here, so I guess I can copy it. So copy bytes as hexadecimal. No, it's yeah, let's I guess do this, and we are starting the packet from 01 again. So let's go back to our notes, and maybe we can figure out what's going on there. Let's get rid of all the previous layers. We don't need them. The same ID is sent, and then 52 is sent. So what is this 52? Okay, how many bytes were delivered originally? Originally, there were delivered here 125 bytes. Okay, no, sorry, the length is actually of the payload is 83. So let's do Python hex 83. Oh, that's for 53. So as we can see, there's like this some like magical number here, and then we get data. So maybe this 52 might be an offset into the data, as in the client says, oh, okay, you send me some data, but you sent me only part of data, which makes sense, right? Like the UDP packet, maximum length of a UDP packet is 64 kilobytes. So if a file is larger than 64 kilobytes, you cannot send everything. So you need a way to fetch like the next portion of the data. And in this case, this is basically like the cursor, right? Like, so we downloaded 52 bytes, and now we request the next byte starting from the offset in the file 52. Let's see what the server actually replied to this. And the server replied length 1, and it's just like length 1. We can ignore these zeros here, that's just padding. But as you can see, the data length is 1, and it just replied 1, but without any additional data. So what I'm guessing is that the server replies 1 if the file exists, and then there's the data. And if there is no more data, then, well, it still replies with 1, but, well, no more data, right? So what we need to do to download our file in that case is we need to do multiple requests, not just one. So let's do it like this, maybe. We will have this like file data, let's call it. And let's make it a list, basically. And we'll be adding the file data here. And then we have the file offset, right? And this is what we start with. We start with offset 0. And here, when we create the packet, we actually use the file offset. Okay, I guess that we can move this a little bit here, which makes sense. So let's do an infinite loop while true. Then we get the data. Now we actually like, we have to check, I guess, like if the data of 0 is equal to this 1, which the server seems to reply in case there are no errors. So I guess if it's not equal, then like something weird happened. We want to be informed about it, just that. Like if something weird actually happens, we will deal with it. But for now, let's just like do this, and I guess like we can exit as well. Otherwise, we can, I guess, skip that first byte. So data, we actually skip the first byte. And if there's no more data, we return, like, or rather we break out from this loop. Otherwise, we add this data to the file data. So file data, append data. There we go. And now in file data, we have the data, but we should return it. But we need to actually like concatenate it together to return it. So let's do this. So we have all parts connected together of the file. Therefore, we should actually get the correct file data here. So let's assume we got it, and we actually want to write it because we are fetching what we are fetching secrets PDF. So let's write to this, or is it secret PDF? It's actually secret PDF. So let's write the data there. And we can also like, I guess, like print to ourselves like download it. How many bytes have we downloaded? We have downloaded, if this works, of course, length of data bytes. Okay, let's run it. And it says it doesn't, like, something didn't work, apparently. It says that something weird happened, which kind of means that the data which we received was... also we are in an infinite loop, I guess, because I haven't ever here incremented the offset, which is also a mistake, but it's fixed now. So what's going on that we are actually getting... Here, well, we are getting this here. Oh, I know, because this is a Python thing. If you just fetch one single index from a byte, then you are getting the code of that byte. If you'd be fetching a range, then you would actually, so if I would do like this would actually get me a bytes type, otherwise it gets me an int type, so now it should work. And it has downloaded 100 kilobytes. Let's see what is in that file. So I'm going to open this PDF, and it shows an error, but it actually shows correctly. And yeah, it's a correct PDF, and it says, there's a flag, a CTF flag, Hexa, congrats, you have found the secret. Not a real flag. For real flags, you have to solve our exercises at hackarcana.com. There are some cool exercises like publicly available, so yeah, you're welcome to join Hackarcana and have some fun. There's also a discount code if you would like to join my Mastering Binary Files, the Complete Journey, or other files and protocols. The Complete Journey course is going to run from April to June, and you are basically, if you join, you're going to acquire all the skills which are needed to do what I just shown you in this case study. You will understand how to use a hex editor, how to use Wireshark, how to look at bytes and actually see them for what they are, see the values there, what are the typical encodings. You'll be able to also implement parsers, implement encoders, decoders, and reverse engineer unknown files and protocols as well. So yeah, you are very much invited. Now, if you want to actually join, let's go back to this page. And what you have to do is go to hackarcana.com, then to workshops, and this is the workshop where all the information is on this page. We will also publish a more detailed agenda. Also, already 600 people have been trained in this course. It had received really, really positive notes, so you can read their testimonials here. And yeah, if you're interested, just click one of these buttons to register now. And that's it for today. So thank you very much. I hope to see you on the course, and see you later. Bye-bye.